We're going to start looking at examples of different polynomials where we might have to use multiple ways of factoring. So far, we've learned on how to organize trinomials through our railroad crossing sign and by finding the GCF. To encounter this problem with our general directions of factor, we have to figure out what is the best method to approach first. Since we haven't encountered any problems where there's been another number besides 1 in front of the x squared, it would be our best guess to find the GCF first and then see if we can factor our remaining terms. Here, I can eyeball what our GCF is going to be since we really can only pull out a coefficient or a number since all the terms don't have a variable. Here we have 3, 3, and -6, and all of them have a factor of 3 in common. Therefore, I can divide the 3 out of all of those terms and see what I have left. I like to think of this as we're pulling the 3 out for dinner and we're putting everything else, all our leftovers that we're not going to use, inside our parentheses, or really inside our fridge. When we divide 3x squared by 3, we're left with x squared. When we divide a -3x by a 3, we're left with a -x or a -1x. When we divide a -6 by 3, we're left with a -2, so we're going to subtract 2. Now we have our 3 as our greatest common factor in front, and we're left with this trinomial from our parentheses, x squared minus x minus 2. Previously, we learned how to use our railroad crossing sign, or really our organizer, to figure out how to change trinomials into two binomials. And in this case, that's what we're going to do exactly. We're going to put our -2 on top to figure out what two numbers multiply to -2, and we're going to put a -1 on the bottom to see what two numbers add to -1. And those are going to be the same two numbers that multiply to -2. Thinking about our list of all the numbers that multiply to -2, it's pretty straightforward. Well, it could be -1 and 2, as well as a +1 and a -2. We see when we add each of those two factors together, we end up getting our -1 and 2 adding together to be a +1, and that doesn't match what we have up there. But our second two numbers, 1 and -2, add to be a -1, which does match what's right there. So we're going to be looking at 1 and -2 as our two factors. I'm going to go ahead and write them up here. And I'm going to use those two factors to help me create my trinomial into two binomials. We know since we're working with an x squared that the first term in each of these parentheses has to be x, because x times x gives us x squared. We can then go ahead and fill in a +1 into our first parentheses from our first factor, and a -2, we're subtracting 2, as our second factor. We just showed how to change this trinomial into two binomials. Now keep in mind we pulled out the greatest common factor of 3 before. We also have to bring it down and include it with our other two parentheses. When we divide out the greatest common factor, it doesn't disappear. We have to include it within our rewritten factored form as well. Just in case you're not sure if our given result is the factor version of our original problem, we can go ahead and check to see if we multiply our two previous binomials and our GCF if we get our original answer. So we really can multiply the 3, the x plus 1, and the x minus 2 really in any order. So I'm going to multiply the 3 times the x plus 1 first, and then I'm going to come back and multiply that times x minus 2. So when I distribute or give away multiplying that 3 times x plus 1, I get 3x plus 3. So now I'm going to multiply that times x minus 2. I'm going to show this through FOIL. You can also use the distributive method as well. So F stands for first, so I'm going to have my first two terms, my 3x and my x. So I multiply those and I get 3x squared. Then I'm going to do my outer terms, so my 3x again times a -2. So that gives me a -6x. My inner terms are going to be 3 and x, so I'm going to add on a 3x. And then I have my L as my last terms, 3 and negative 2, so those multiply to be negative 6. We can combine any terms that are alike, and I see the negative 6x and the positive 3x are alike, so I'm going to combine them together to get negative 3x, and I'm going to bring down my other resulting terms. So now I have 3x squared minus 3x minus 6, which if you compare that to our original problem, it does match. Therefore, we know our factored form of 3 times x plus 1 times x minus 2 is the lowest factored form.